Okay, today we'll start with normal distribution, second part. In previous lecture, we have studied more about normal distribution, definition of normal distributions, properties of normal distributions, and the main three conditions we have studied, which satisfied by normal distributions. Today we also start with normal distribution as a second part. First of all, we will try to uh, define the normal distribution and try to prove normal distribution from the Poisson distribution as a limiting case. Okay. Okay, normal distribution is a continuous distribution. It is derived as the limiting form of the binomial distribution for a large values of n and p and q are not very small. The normal distribution is given by the equation f of x. This is the probability density function for normal distribution equals to 1 divided by sigma square root over twice pi and e to the power minus x minus mu divided by 2 sigma square x minus mu whole square. Actually, here sigma is the standard deviation and mu is the mean, and pi equals to 3.1416. And probability density function also can be written as f of z, where z equals to x minus mu divided by sigma. We can write this whole probability density function like this: f of z equals to 1 by twice root pi e to the power minus half z square. Actually, z equals to what? X minus mu divided by sigma. Sigma is the standard deviation, okay, and mu is the mean. Here mean equals to 0 and standard deviation equals to 1. Then it is known as the standard form of normal distribution. Okay, for the normal distribution, we must remember it is a continuous probability density function. But in previously, we studied about binomial distributions and Poisson distributions, which was discrete probability density function. But it is defined in probability density function for continuous types. It is a continuous probability density function, that is random variables can take on any values within a given range. That means height, weight, marks, every samples will be considered for that. But in discrete, we have to take the samples in a discrete way. Secondly, the developed by 18th century mathematician astronomer Carl Gauss is also it is also called Gaussian distribution. That means normal distribution discovered by developed by in 18th century a great mathematician Carl Gauss, uh, called Gaussian distribution. It is symmetrical and unimodal. That means one peak, unimodal. That means it is also symmetrical. Since it is a symmetrical, its mean, median, mode all coincides. That means all three are same. Look like same three values. That means mean, median, and mode. For symmetrical curve, all these three are same. And the tails are asymptotic to horizontal axis. Horizontal axis means actually along x-axis. Okay, along x-axis the tail are asymptotics to horizontal axis, that is curve goes to infinity without touching horizontal axis. X-axis represents the random variables like height, weight, etc. Okay, x-axis represents the random variables and y-axis represents its probability density function. Remember it. For every values of x, we will get every value of y. That means probability density function along y-axis and random variables in x-axis. You have to remember it. Area under the curve tells the probability. Area under the curve tells the probability. The total area under the curve is 1 because the highest probability is 1. That means 100%. We will consider mean equals to mu and standard deviation as sigma. The defining a normal distribution. only two parameters are considered. So one is mean and other is standard deviation. We have seen in in the definition of normal distribution, mu and sigma is the present. Same means different standard deviation, same standard deviation, different means, or maybe different means and different standard deviation. Actually, normal distribution maintains these three mm, three conditions for the two parameters. One is mean and other is standard deviation. Actually, if you draw the normal distribution curve, this is the along the, this is the sample, and this is the probability density function. Actually, this is the symmetric curve. It is called symmetric because if we divide it into two parts, okay, you can divide it into two parts. One is left, this is the left tail, and this is the right tail. Okay, this is the right one, right, and this is the left. And here 50% in this area, that we can divide it into whole area into two parts. One is 50% this, and other 50% is this. Okay, that means this is symmetrical curve. So mean, median, mode, etc. are same for this curve. This is the standard normal distribution curve. Here, this 50% divided into three parts. One is this 50% divided into three parts. One is 1/4, and this is 0.135, and this is 3.34. We can divide it into like this. Here, this symmetrical curve. Okay, this symmetrical curve. This is the left tail, and this is the right tail. This area indicate the actually probability. Okay, and in this area, this red area, actually 68% from this total area, and this is the, this total area 95.5% of data, and this total area 99.7%. That means total 100%. For some error here, actually this is the error. Okay, this is the left error and this is the right error. This is why point something missing. Now area under the curve, the mean may be plus minus 1. Standard deviation covers the approximately 68% of the area under the curve. Standard deviation covers the area how many? 68%. And if the mean plus minus 2, standard deviation covers the approximately 95.5%. If we consider this condition, mean plus minus 2, then will be what? 95.5% area. And if the mean plus minus 3 standard deviation, okay, then the total area will be what? 99.7%. Actually, this is the condition for the normal distribution. Mean plus minus 1, first condition, 1 standard deviation. Mean plus minus 2 standard deviation covers the approximately this area, and mean plus minus 3 standard deviation covers this percent of area of the total curve. Okay, total curve. This you have to remember. This standard deviation normal probability density function. In the standard normal probability density function, mean equals to 0, standard deviation equals to 1, and z equals to, we consider in the probability density function, z equals to what was? X minus mu divided by sigma, where z is the number of standard deviations from x to mean, also called z score. This z is defined as number of standard deviations from x to mean, also called z score, where x is the value of random variables. Actually, practical problem, we can draw this for the figure like above example. The height of a height was 147 centimeter with a standard deviation. This, what is the probability of this? Actually, this percent. And mean demand of an oil is 1000 liter per month with standard deviation this liter. If 1200 liters are stocked, then this will be 78%. If 95%, then what was the stock? This is the liter. Yeah, this is the practical problem for normal distribution. We'll study about this practical problem later. Okay, This is the actually explanation of normal distribution and properties of normal distribution. Now we will try to derive the normal distribution from limiting form of Poisson distribution. Actually, using Poisson distribution, we will try to derive the normal distribution. Now, normal distribution is a limiting form of Poisson distribution with the parameters m tends to infinity and x tends to infinity. Actually, m is the mean. Okay, m is the mean and x is the actually sample. If it's infinite, m tends to infinite and x tends to infinite, then we can derive the normal distribution as a limiting case of Poisson distribution. The probability density function of the Poisson distribution with parameters m is given by this. We know from probability density function. A probability density function p of x equals to e to the power minus m to the power x factorial. Okay, x equals to what? 0, 1, 2, dot dot infinity. Now we have to recall another approximation for x factorial, the Starling approximation. It is the new formula for you. I hope everybody will understand. Try to remember this. Starling's approximation to x factorial for the large x. Okay, x factorial equals to is root over twice pi, root over twice pi, root over twice pi e to the power minus x to the power x plus half. Actually, this is the formula of Starling approximation. Understand? Starling approximation. Okay. X factorial equal to what? Square root over twice pi e to the power minus x to the power will be what? X plus half. This is the formula for what? X factorial. Now, putting in this equation, that means probability density function x factorial for this Starling approximation, we can write this. Okay, therefore limiting case for the probability density function of Poisson distribution, limit will be what? M tends to infinity, x tends to infinity. Okay, we have to consider these two limits. A limit probability of x equals to limit m tends to infinity, e to the power minus m, e to the power minus m to the power x, and this is the Starling approximation, x factorial value. Okay, understand everybody? This is the x factorial value. Okay, x factorial equals to what? Starling approximation square root over twice pi e to the power minus x. This is the separate, and x to the power x plus half. Just putting x factorial value. Remember this limit, m tends to will be infinity, and x tends to what will be, of course, infinity. This equals to can be written as limit m tends to infinity e to the power x minus m. Okay, e to the power x minus m, and here m divided by x, taking m divided by x in a body, m divided by x to the power what will be? X plus half, x plus half. Okay, x to the power x plus half, and m to the power taking x plus half. Then there is m to the power half is extra. This is why we have given in denominator m to the power half. That means root m. Okay, root m absent here. By taking root m in here, and this m to the power half will be cancelled, and x to the power x plus half present here. Okay, now this e to the power minus x and e to the power minus m will be e to the power x minus m. Okay, e to the power minus x and e to the power minus m combinedly e to the power x minus m, and m to the power x, and here taking square root over m, that means m to the power half. We can take this m by x to the power x plus half. Now this is for m large. M is very large, m will be tends to infinity. Now this can be written as, this is the constant 1 by root over twice pi m. This is the constant, so we have taken it before the limits, and limit will be e to the power x minus m, m tends to infinity, m divided by x, x plus half. Let x minus m divided by root m equals to z. We have considered this parameter z, x minus m divided by root m will be z. Then by cross multiplication, x minus m equals to what will be? Root m z, z into root m. Okay, so this x equals to can be written as m plus z root over m. Okay, just putting these values x, okay, from this. Now we get from this parameter x equals to m plus z into root over m. Now taking x divided by m, x divided by m, just dividing by m on both sides, we get x divided by m equals to m divided by m what? 1. And this divided by m what? Z divided by root m, because m can be written as square root m whole square. This way root square root m and square root m will be cancelled after dividing. So z divided by root m. We can write this equals to 1 plus z divided by root m to the power minus 1. Can we write? Just in taking inverse, this is the x by m, okay, x by m, and this is what? M by x. That means inverting on both sides, inverting on both sides. And this inverse what will be? 1 plus z root z divided by root over m whole to the power minus 1. Understand? Just taking inverse on both sides.
Yes, sir.
Now again let pi, actually this is the phi, let pi equals to e to the power x minus m divided by x whole to the power x plus half. That means this, we have considered this whole pi. Okay, this is the function of, we consider phi equals to e to the power x minus m divided by x to the power x plus half. Okay, now x equals to what was in our, x equals to m plus z into root m. Okay, m plus z into root m. Now putting here x equals to this m plus z root m here, then we get only x cut. Okay, will be cancelled, then only e to the power z root over m will be exist. Then m by x equals to what? M by x equals to this. Okay, m by x equal to what? This. Now putting m by x here, then power x plus half will be what? Multiplied with this power x plus half. Okay, and x plus half, putting x equals to what? M plus z root m, m plus z root over m. We get m plus z root over m for x, this half. Okay, now taking logarithm on both sides. So log phi equals to log e to the power this. That means only this log e will be cancelled by the properties of logarithm. So only this is exist. Then plus log this. Okay, plus log this, but this is the power, this will be existing before the log, minus m plus z root over m plus half, then log this, log 1 plus z by square root over m. Now log pi equals to z root over m, this m plus z root m plus half, but this is a formula, log 1 plus x formula, log 1 plus x formula. Log 1 plus x formula what? X plus x minus x square by 2 plus x cube by 3. Okay, x cube by 3 minus in this way. Log 1 plus x formula what? Log 1 plus x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4. Okay, in this way. Now just z root over m, after multiplication this m into this, what will be? M into multiplied with this, m can be written as root m whole square. So root m square root over m square root over m will be cut. So only z root m will be exist. Okay, then putting m multiply this, what will be? Will be cut, only minus minus plus z square by 2. Okay, z square by 2. Now this z root m multiplied with first one, what will be? Z root m multiplied with this root m will be cancelled, and z what? Z square plus minus z square. plus factor containing power of m in the denominator. Okay, all rest of the power, there are infinite number of terms, okay, containing m, factors containing power of the m in the denominator, remember it, denominator. So limit log phi, this was the value of log phi, taking limits on both sides, m tends to infinity, taking limit m tends to infinity, log phi can equals to what will be, this is the square root over m, and this is the minus plus z root m plus minus z root m will be key, what will be cancelled. Okay, this will be cancelled. So log phi equals to, can be written as half z square minus z square, what will be only half z square. Okay, plus half z square minus z square, what will be after addition minus half z square. So and all factors will be containing m in denominator, since m tends to infinity, m is very large, that means m tends to what, infinity, putting m equals to infinity, we get 1 by 0 1 by 0 1 by 0 1 by infinity 1 by infinity 1 by infinity in every term. Okay, then 1 by infinity what will be 0, 1 by infinity what will be 1 by infinity 1 by infinity, what will be in every term will be 0, since m tends to infinity. So m tends to limit m tends to infinity, log phi equals to what, only minus half z square. So phi equals to what will be, taking exponential on both sides, e to the power minus half z square. Okay, taking exponential function on both sides, phi equals to e to the power minus half z square, and e to the power z square means what, x minus m divided by what was z equals to what was z equals to what was this, x minus m divided by root m. Okay, this is the z, x minus m divided by root over m. So just putting value of z square, we get this square, x minus m whole square divided by twice m, putting value of z. Hence limit probability function, probability density function for Poisson distribution, m tends to infinity x tends to infinity, will be given by 1 by root over, just putting 1 by root over twice pi m. Okay, 1 by root over twice pi m, and this value pi. Okay, this whole value pi, this whole value what, pi, whole value. So 1 by root over twice pi m e to the power what, this pi, this pi. Okay, so f of x equals to 1 by root over twice pi m e to the power x minus m whole square divided by twice m. X must be minus infinity to plus infinity, because for exponential function. So if we put x minus m divided by root m equals to x minus mu divided by sigma, since mean and variance of the Poisson distribution are same, do you know, we have derived it, we have derived mean of Poisson distribution, variance of Poisson distribution, and we saw that both are same. This is why x minus mu and sigma can be written as from Poisson distribution. So finally we can write f of x equals to 1 by root over twice pi sigma square e to the power minus half x minus mu divided by sigma whole square, where x lies between minus infinity to plus infinity. Actually this is the probability density function of the normal distribution with mean mu and variance sigma square. I hope everybody understand. A little bit lengthy. Uh, the chief characteristics of the normal distribution and normal probability curve. Actually, the normal probability curve with mean mu and variance sigma square is given by this. We have proved this from the limiting case of Poisson distribution. Actually, this has the following properties. Actually, there are many properties, above 11 properties. Okay, 11 properties. This is very important for you, these properties. for this probability density function of normal distribution, the curve is bell shaped and symmetrical about ordinate. That means x equals to mu. And if x is increases numerically, f of x decreases rapidly after the point x equals to mu. We have seen this, okay, in our this is the curve, okay. If x increases, then the value decreases. And the maximum ordinate at x equals to mu and is given by y equals to this. If you put x equals to mu, this will be what? 0, right? If we put x equals to mu minus mu, what will be? 0.
0.
That means e to the power 0. E to the power 0 means 1. This is why this is the maximum, 1 by root over twice pi sigma square. Okay, x equals to mu, the maximum ordinate. We get ordinate means what? Value of y equal to f of x. Okay, the functional value will be maximum when x equals to mu, e to the power 0. Then this is the 1 by root over twice pi sigma square. Now again, points of inflection are equidistant from the mean. Okay, point of inflection will be equidistant from the mean. This is the equidistance. Okay, from the mean. Mean is the this point mean. If you take any point from here, from left and right, then this will be equidistant from what? Mean. Okay. Now the curve extended to infinity on either side of the mean. Okay. This can be extended to infinity. This will be infinity minus infinity, and this will be what? Plus infinity from the mean. Okay. Now arithmetic mean, median, mode of the distribution coincides. Coincides means what? Same. This will be same here in this point. Okay, mean, median, mode will be same. So the all odd moments are 0. All moments will be what? 0. Remember it. This is the important properties of normal distribution. Linear combination of independent normal variates is also normal variate. Mean deviation about arithmetic mean is root over 2 by pi sigma. Sigma equals to what? Actually variance. This is approximately we get 4 by 5 sigma after putting the value of pi. Quartile deviation is equal to twice 2 by 3 two-third of sigma. That means sigma means what? Standard deviation. Another 11 number properties, probability of this between x minus mu between this will be 0.68%, and probability if mean will be plus minus twice mean plus minus 2, okay, of the standard deviation. We have this is the mean plus minus standard deviation covers approximately what? 68%. Actually this is the properties. Okay, and if the mean plus minus 2 standard deviation covers the approximately what? 95.5%. This is the properties. Okay, mean lies between what? Lies between plus minus, mean lies between plus minus 2 sigma. Sigma means what? Standard deviation covers 95%, 95.44% of this area. That means this area, 95% area. Okay, and if the mean plus minus 1 standard deviation, that means mean plus minus mu will be covered 68% area. And if the mean plus minus 2 into a standard deviation, then covers 95.5%. If the mean covers plus minus 3 standard deviation will covers what? 99.7%. That means this 3 into sigma plus minus for this range mu minus 3 sigma plus x lies between this plus minus 3 sigma will cover what? 99.73%. Remember it. And if this x minus mu divided by sigma, this is the actually value of z. Okay, z lies between 1.96 minus 1.962 plus 1.96 will be 95%. And if z lies between this, then will be 99%. We have to remember these properties of what? Chief characteristics of normal distribution. This is the continuous probability density function. Okay, now mean for the normal distribution. We know from the mean equals to what? Minus infinity to plus infinity, f of x, x dx. This is the formula of mean from the probability density function. Okay, mean will be what? Integration minus infinity to plus infinity, f of x, x dx, x into f of x dx actually formula. And this f of x comes from what? Normal distribution, probability density function for normal distribution, 1 divided by sigma root over twice pi e to the power minus x square by twice sigma square. This can be written as 1 by sigma root over twice pi e to the power x by mu equals to, if we consider x by mu equals to t, then x by, then this will be what? T square by 2 e to the power minus t square by 2. X equals to what? Sigma t. X equals to sigma t. Then dx what will be? Taking differentiation on both sides. Dx equals to what? Sigma dt. Sigma dt. Then there are two sigma. One sigma will be cancelled. So another sigma will be here. Sigma divided by root over twice by minus infinity to plus infinity. Then t, this t into e to the power minus t square by 2 dt. Actually, we have to integrate this. Understand? Now this integration, if we consider minus t square by 2 equals to z, or um, u or b, any substitution, then ddt will be what? Will be cancelled. So this integration can be written as sigma divided by root over twice pi e to the power what? Just e to the power x formula, e to the power x minus infinity to plus infinity. Actually, this is the even function. This is why this value will be 0 after putting infinity plus infinity for t, that means e to the power minus infinity, e to the power minus infinity what? 1 by e to the power infinity, 1 by e to the power infinity what? 1 by infinity, 1 by infinity what? 0. This is why this whole value what will be? 0. That means mean equals to 0. For normal distribution, mean equals to 0. Now for the same case, the standard deviation for the normal distribution, the standard deviation for the normal distribution. Actually, raw movements, second raw movements can be written as integration x square f of x dx. Just taking x square f of x dx. That means these second raw movements can be written as equal to minus infinity to plus infinity x square f of x means what? Probability density function for normal distribution. 1 divided by sigma root over twice pi e to the power minus x square by 2 sigma square. Now putting x square by 2 sigma square equal to what? T. Substitution process. Okay. X equals to what will be? Root over 2 sigma t to the power half. Then taking differentiation on both sides, dx equal what will be? Sigma root 2 will be constant, t to the power half formula what will be? Root over t. Then we root over x formula what? Differentiation 1 by 2 root x. Do you know? 1 by 2 root t here, and the dt with respect to t. Now dx equals to this. So the second raw moments equals to minus infinity to plus infinity. X square means this. Okay, this is the value of x square. This is the x square equals to just multiplication t into 2 sigma square. Then 1 by sigma root over twice pi e to the power, just putting x equals to what? X square equal to 2 sigma square t. 2 sigma square t divided by 2 sigma square. So 2 sigma square, 2 sigma square will be cancelled. Then dx what will be? Dx will be this whole 2 root over 2 sigma divided by 2 t to the power half dt. Now the integration will be with respect to t. So minus infinity to plus infinity, 2 sigma square t, 1 by sigma root over twice pi e to the power will be only t. 2 sigma square will be cut. So e to the power only minus t. Then root over 2 sigma divided by 2 t to the power half dt. Okay. Now taking all constants, this root 2 sigma, this 2, and this sigma, this root 2 is pi, all taking altogether. with in a all constants are here before the integration. 2 sigma square root over sigma, sigma root over twice by this 2, minus infinity to plus infinity. This will be what? This is the t half. Okay, this t half can be, and there are another t. So t into t divided by t half. T divided by t half, what will be? T divided by t half, what will be? T to the power 3 by 2 minus 1. 3 by 2 minus 1, what? Actually 1 by 2. Okay, t to the power half can be written as t to the power 3 by 2 minus 1, e to the power minus t. Actually this is the gamma function. Do you know this function? This is the gamma function. Gamma function, second Eulerian function, gamma n equals to what will be? 0 to infinity x to the power m minus 1 e to the power minus x. This can be written as gamma n if 0 to infinity. Okay, if 0 to infinity. So if minus infinity to plus infinity, this total function can be written as 2 into 0 to infinity, because this is the odd function, and odd function can be written as like this. Understand? So e to the power t to the power t to the power 3 by 2 minus 1 e to the power minus t can be written as total integration 0 to infinity. It is the properties of integration, properties of definite integrals. Minus infinity to plus infinity can be written as 2 into 0 to infinity. Okay, t to the power 3 by 2 minus 1 e to the power minus t. This is the whole formula for gamma n. Gamma 3 by 2. Gamma 3 by 2. This is the n equals to 3 by 2 here. Gamma 3 by 2. But gamma 3 by 2 can be written as half into gamma half. But gamma half equals to root pi. Remember it. Gamma half equals to root pi from gamma beta function. Gamma half equals to root pi. This root pi will be cancelled. So only sigma square. That means this moment equals to sigma square. But mu2 equals to what? We know second corrected moment. Second corrected moment, relation between raw moments and corrected moments. So second corrected moments equals to second raw moments minus first raw moment whole square. This is the relation. We have established it. The relation between raw moments and corrected moments in midterm exam, before the midterm exam. So mu2 equals to mu2 dash minus mu1 dash whole square. Actually just putting this value, mu1 equals to 0. We have derived mean equals to what was 0. And mu2 dash what? Mu2 dash only sigma square. This is why second corrected moment mu2 sigma square. And this is the actually standard deviation. Standard deviation. This is the actually variance. So taking a square root on variance, we get standard deviation, because standard deviation whole square equal to variance. This is the definition of gamma function. Okay, 0 to infinity e to the power minus x, x to the power n minus 1 dx denoted by gamma n for n equals to n is positive, and is called the second Eulerian integral or gamma function. We have used this formula actually. On the other hand, gamma 1 equals to 1, and gamma half equals to what? Root over pi. Remember it. We have used this formula, gamma half equals to root over pi. Okay, this is the actually gamma 3 by 2. Gamma 3 by 2 can be written as half into gamma half. How? Actually there is a formula for this, because gamma n plus 1 can be written as n into gamma n. Okay, if there is n equals to half, then half into gamma half. Okay, that means gamma 3 by 2 equals to what? Half into gamma half. Understand?
Yes, sir.
Gamma 3 by 2 equals to half into gamma half, because 3 by 2 can be written as half plus 1. So this is formula used here. Another formula was what? Gamma half equals to what? Root over pi. Root over pi. So this is the gamma function, gamma n formula, and we have used here is the n minus 1. N minus 1, n means what? 3 by 2. This is why gamma 3 by 2. And gamma 3 by 2 can be written as gamma n plus 1 equals to n into gamma n. So gamma half equals to what? Another formula, root over 5. So root over 5 cancelled. Then sigma second corrected raw movement, second raw movements equals to sigma square. But using the relationship between raw moments and corrected movements, second corrected moment equals to this. We get sigma square. So standard deviation will be the square root of what? Sigma square. Because this is the variance. If we take standard deviation from the variance, we must take a square root on both sides. Then standard deviation will be sigma. Now median of the normal distribution. If we take A as the median, then it is divides into total area into two equal parts, half of equal halves, so that minus infinity to A f of x dx equals to half A to infinity f of x dx. Because we can divide this into two parts. Okay, this is the half portion and this is the another half portion, and equal portion. This is the equal portion. So if we take the median, you can take the half of this curve. So minus because the total curve is minus infinity to plus infinity, so you can take minus infinity to a f of x dx equals to half a to infinity f of x dx. Same. That means because the median can be divided into two parts, where f of x is the probability density function for normal distribution, and this is the formula for normal distribution. Suppose the median a is greater than mean mu. Just taking let us consider median a is greater than mean mu. That means we can write minus infinity to mu f of x dx, mu to a f of x dx equals to what? Half. Okay, because minus infinity to mu f of x dx what will be? Only half. But we have considered median is the greater than mean, because minus infinity to mu f of x plus mu to a, because we are taking minus infinity to a. Minus infinity to a equals to what? This is the formula, minus infinity to a, median formula. Okay, this is why you consider this into two parts, equals to half. And actually this is the half, because minus infinity to mu f of x dx equals to half, and this equals to what? Actually 0. Thus a equals to mu. Similarly we can prove taking median a less than mean, then we also will get what? A equals to mu. So median equals to mean equals to mu for normal distribution. These three are identical, same. Understand? We have studied in properties of normal distribution. Okay.
Yes, sir.
Now mean deviation about mean. How we'll get the mean deviation for normal distribution? Actually mean deviation can be written as expectation of x minus mu, absolute value of x minus mu. And this is from the probability density function, minus infinity to plus infinity f of x mu x minus mu into f of x dx. Okay, just using probability density function. Now minus infinity to plus infinity, just x f of x dx. X means what? X minus mu. Now taking x minus mu divided by sigma equal to z, just substituting this, dz will be what? Dx divided by sigma. Mu will be 0 because constant of differentiation will be what? Differentiation of constant what will be? 0. This way dz equals to this. Now substituting this, just considering e to the power half. This will be half. X minus mu divided by sigma square will be z square. This way 1 by root over 2 x minus mu what? X minus mu equal to z sigma. Z sigma. So this can be written as dz equals to 1 by root over 2 t to the power minus half dt, where z equals to this and dz equals to this. So just putting from here, we get x minus mu what will be? Z sigma. Z sigma absolute value will be just sigma, then 1 divided root over twice by minus infinity to 0. minus z e to the power minus z square by 2. Just putting this x minus mu divided by sigma equals to z here. We get this plus 0 to infinity. We are dividing this integration into two parts, minus infinity to 0 and another is 0 to infinity. Same function z e to the power minus half z square dz. Just dividing into two parts. One is for minus infinity to 0 and other is for what? 0 to infinity. Now there are actually this will be 0 because this is the even function. For even function this value will be what? 0. Now this multiply with this, we get 0 to infinity z into e to the power minus z square by 2, 0 to infinity. So this sigma 2 and root over 2 will be cut, then we get root over 2 divided by pi minus e to the power what? Z square by 2. Then this is just putting in infinity value for z, we get this what? Actually e to the power minus 0 minus infinity e to the power minus 1 by e to the power infinity equal to what? E to 1 by infinity, 1 by infinity equal to 0. This is why we get only sigma into root over 2 divided by 5. This will be minus 0 and e to the power 0 what? 1. This is why only 1. E to the power 0. Just putting z equals to 0 what? 0. Here we get e to the power 0. E to the power 0 means what? 1. And this minus and the integral minus will be take plus 1. So we get sigma into root over 2 divided by 5. This means what? Actually approximately 4 by 5 sigma approximately can be written as this. Actually this is the mean deviation we have proved. This is very important for you. And similarly process we can find mode for the normal distribution using same probability density function of normal distribution. We can find out mode where we know mode is the value of the variate x for which f of x is maximum. F of x will be maximum if if this is the this value e to the power something value, what will be 1. If this is value, highest value is 1, that means if x minus mu divided by 2 sigma square will be 0, e to the power 0 means what? 1. This is why we considered to get maximum value of fx, x minus mu divided by 2 sigma square equal to what? 0. To get the highest value of or maximum value of f of x, this must be what? 0. And this 0 will be give x equals to mu. That means maximum f of x, maximum f of x higher actually is maximum f of x. This is the mode position for this normal distribution. So this to get highest value of x, this is the total f of x. Okay, to get highest value of x, we have considered x equals to mu, x equals to mu, x equals to mu. If you take x equals to mu, f x equals to mu, then we get this will be 0. Okay, that means for highest value of x will give the mode. That means x minus mu, this will be 0, or x equals to, putting x equals to mu here, we get x equals to mu. So the mode is the mu, and modal ordinate what will be? Ordinate means value of y. Ordinate means value of y, and if it and this mu is the value of x, value of abscissa, and for this mu, putting x equals to mu here, we get f of x. F of x what will be? This 1 by sigma root over 2s pi. Understand?
Adab sir.
Okay. Okay, thank you everybody. Okay, next day we will start normal distribution for the what? Third part. Next day we will start third part. But till then, thanks to everybody.